Okay, it looks like we are live here, and I know that there'll be a couple students waiting, and so just as a brief introduction, if you've got any questions, ACT-related questions, go ahead and throw them into the chat. Just let me know what form code you're looking at, what section you're looking at, what form code you're looking at, what section you're looking at. Obviously, there'll be a couple of times when students don't have any questions to ask, and so I'll pick through. Don't have any questions to ask, students usually struggle. I'll pick through, and any questions to ask, students usually struggle. I'll pick through, and again, keep that chat open, that's where I'll follow. Again, keep that chat open, that's where I'll follow. Also, I'll post this after, so if you just have a question or two, or you gotta run, or you're getting bored with my answer to a question, that's okay. I'll post it after. I'll have timestamps by section for each question, so you don't have to worry about going back and finding exactly, oh wait, where did he explain the question, worry about going back and finding exactly, oh wait, where did he explain the question, worry about going back and finding exactly, oh wait, where did he explain the question, worry about going back and finding exactly, oh wait, where did he explain the question, worry about going back and finding exactly, oh wait, where did he explain the question, worry about going back and finding. So I'll just go ahead and get started with a question that I've seen pop up a few times recently, and that is from Form 8, and that is from more recent ACTs. That was from December 2017. For whatever reason, people tended to struggle on the math section here. So I just want to open up question number 60 there. Question number 60 there. Question number 60 and so the issue with this question is that it is, it's an Algebra 2 question, but it's also kind of a number theoretical question that involves a little bit of intuition and a little bit of knowledge to intuition. Just read it real quick. It says, what solution of this equation is x equals minus 1, which the following describes these other two solutions. So there's a couple of ways that you can go about this. When you see, hey, I know 1 is x is equal to minus 1, when you see what might occur to you is, I remember back in Algebra 2, I learned Descartes' signs, I learned some stuff like rational roots theorem, okay, and things I learned back to you. The thing that you want to keep in mind on a question like this is that the ACT is really an easy exam. So if you're thinking anything crazy, or you're trying to really dig deep into your Algebra 2 knowledge, you're probably working a little bit too hard. So if I come across this question and I think of any of those things, just scrap it. The easiest thing to always do is just plug in. Just plug in a question, plug in the values, see what sticks. So they tell you, hey, one of the solutions is x is equal to minus 1. So if you plug that in, you're going to find, okay, well, it's equal to 0, right? You know that's the solution. You're going to find, okay, well, it's equal to 0, right? You know that's the solution. You also want to take advantage of the fact that, if x equals minus 1 is a solution, then that means, of course, hey, x minus minus 1 is a factor. So you know the factors there, and you can do a little work. Okay, so if I take fx here, and you can do is equal to, so if I take fx here, plus x plus 7, I know that that's going to be x minus minus 1, and then times some other polynomial, right, some other stuff. If I can figure out what that stuff is, I can figure out the other two. If I can figure out what that stuff is, this is one way to go about it. If you know a factor, divide it out. This is one way to go about it. If you know a factor, synthetic division, so if we were to pull out x plus 1, I'll just go ahead and synthetically divide there. So if we were to pull out minus 2, 1, and 7 are my coefficients, and I'm dividing out negative 1, and I'm dividing out negative 1. 6, 7, and 1. So that means that the other factor, right, when I divide out that x plus 1 is 4x squared minus 6x, right, when I divide out that x plus 1 is 4x squared minus 6x, right. So what do I do with that? Well, this is easy, right? This is something that I can work with. This is something that I can This is easy, right? This real basic algebra 1, I know you've got that class. So you factor that, you'll find the other two solutions, and you're good. So the easiest way to do this problem is just to graph it, right? So if you have this equation, plug it into your vacuum calculator, right? Graph y equals 4x, plug it into your vacuum calculator, graph that, and see what the roots are, right? Graph it and find roots equal to 0. Don't see what the roots are, especially if you're the exam and really stressed out and you're like, oh my god, what do I do? I'm not going to get a 36. Just go ahead and graph that. You got a graphing calculator. Just go ahead and graph that. You got a graphing calculator. Just go ahead and graph that. It's echoing. Oh no. It's echoing. See, let me go ahead and switch. See, let me go ahead and switch the mic Okay. Echoing. Wasn't echoing last night. What a shame. 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 Echoing. Wasn't echoing last night. See if I use wasn't echoing last night. Different audio streams. Wasn't echoing last night. Different audio streams. You turn that different audio down a little. 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 You turn that different. Okay, that might have made it a little better. Hopefully. Okay, that might have made it a little better. Hopefully. Okay, I'll figure something out 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 better. Okay, did that make a difference? Okay, did that make a difference? It did. Wonderful. Did that make a difference? No, it didn't. No. It did. Wonderful. Did that make a difference? No, it didn't. No. It did. Wonderful. No, it didn't. No. I'm driving anyone listening crazy. Shame. Watching me be angry in real time. Let's see. Okay, it's unmuted, but it might just echo again. I hope not. It's unmuted, but it might just echo again. I hope not. It's unmuted, but it might just echo again. Ay, ay, ay. Unmuted, but it might just echo again. Ay, ay, ay. Unmuted, but it might just echo again. Ay, ay, ay. Unmuted, but it might just. Okay. 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 I think I fixed the problem. I fixed the problem. Now, if I turn my speakers off, it shouldn't be an issue. Now, if I turn my speakers off, is that right? Now, if I turn my speakers off, is that right? I changed the sound settings. I changed the sound settings. I changed the sound settings. Does not. Please tell me. Does not. Please tell me. Does not. Please tell me. Try to listen with headphones. 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 Let's see. Let's see. Let's see. Please be no echo. Please be no echo. Please be no. Oh, please be no. Oh, please be no. Oh, please. Try again. I think that did it. That did indeed do it. Okay, wonderful. Great news. Okay, so let me answer your question now that I've got that sorted out. So you said, let's see, you said, it's all right, thank you. You said, let's see, I have my next ACT on Wednesday. I just started studying now. I got a 24 on my first time, and math was my strongest section. I really want to get a 30 plus. I have a 4.0 GPA. I can't seem to do well on the ACT. Okay. I want to address the second statement you made, which is I can't do well on the ACT, but I have a 4.0. It's really important to recognize that a lot of the skills that you're learning in class are very specific to problems at hand. Okay, so when you're working with problems in class, say it's for English, which is a huge problem because your teacher probably assigns you readings to do that you might not even read, right? You just read the Spark Notes or something like that. You do them, but you're not consciously thinking about what skills you want to take from that assignment to carry over into the future. When you're doing a math assignment, right, let's assume you're in calculus or something like that. Let's say your calculus teacher gives you a homework assignment, you do it, great. That doesn't apply to the ACT. And as you go through, if you ever fall behind, there's no saving grace there, right? If you get a C on an exam, you can still get an A in a class and keep your 4.0, but that doesn't mean you actually understand the stuff, okay? So it's very much a use it or lose it problem, right? The questions on the ACT are, on the math section at least, very specific. You either remember something from Algebra 2 or geometry, or you don't. There's not really an in-between for many of the questions on there. Maybe 15 questions per exam. If you don't know logarithms, if you don't know what sine and cosine mean, there's just no way you're going to be able to get those questions correct. So that's one thing, right? One thing is you have to go back and review. And that's the toughest part for people who have straight A's, who have really good grades, is they think, okay, well, if I got A's, if I have a 4.0, I know my stuff. But that's not necessarily true. So go back and review. Don't be afraid to go back and open up an Algebra 1 textbook or something like that to make sure that your fundamentals are really strong. When it comes to the English portion, you never learn grammar. Nobody teaches you grammar, right? Your first grade teachers probably taught you to put an apostrophe in the word can't. They probably taught you, hey, when I use and, that links two things. But when it comes down to using commas properly and proper syntaxes for using a colon or something like that, nobody ever teaches you that properly, right? Your middle school teachers probably didn't have you sit through grammar workbooks, and they probably themselves didn't know the grammar rules very well, right? Because they never had to study them for any particular exam. So that's one problem. When it comes to the reading on the ACT is very much just, do you know how to skim and read quickly, right? It's more a time crunch than anything else. You're not reading those texts and trying to piece apart the social context of any of those works, right? You're not on the ACT, right? You're not pulling apart what an author's influences were and what was going on in the time period when the text was written. The ACT is just like, do you know what this word means at line 38, right? And so for a lot of us who are trained in English, especially to try and look for the bigger picture, right? To try and find something a little bit more complicated than what's going on just kind of on the surface level of the text, that's really difficult. The ACT really throws us for a loop because it says, okay, well, forget all of the complicated stuff that your English teachers taught you. I just want to know if you can figure out that the text says Orville got mad at Wilbur because, you know, he broke their photo, right? Why did Orville and Wilbur get mad at each other? Well, he broke the photo, right? There's nothing more than that, okay? So I think that's a big problem that a lot of students have. And on the science section as well, right? If you've taken AP Chemistry, AP Biology, you've memorized a lot of facts, you've learned how to do a lot of different chemistry problems or physics problems, but that doesn't necessarily translate to interpreting data and thinking like a scientist, right? Maybe you've done some lab experiments in physics, maybe you've done some lab experiments in bio or chem, or whatever science classes you've taken, but they tell you, hey, step 1 is this, step 2 is this, step 3 is this. This is exactly what I want you to write in your lab report. And so when an ACT throws you a question that says, hey, well, why do you think that the scientists mixed this mixture, right? Why did they wait a little while before they made this measurement? What can we reasonably conclude from these data? Well, that's not something that you've ever worked with. Right? So I think that's the biggest issue that students find. Kind of a TLDR on that, long story short, your classes don't adequately prepare you for the ACT. There's just no way around that, right? The ACT is a very specific exam that does test some important skills that you're probably not getting in your classroom at school. So I hope that does a little bit to answer your question. If you've got, if you've got specific issues with any problems, that would be good, because then I can get a really strong sense for exactly what you do know and don't know, and see if there's kind of a discrepancy between, okay, well, I have this rote knowledge that I've gotten in class, but then the ACT asks the question about it, and suddenly I don't feel like I have any idea what the heck is going on. So if you can think of any questions that have come up, or even just types of questions, I'd be able to give you some indication of where you should go in your studying and what you should do in preparation. I know Wednesday rather is really close, but you can actually get a lot done in 2 days, especially because today's a holiday, so hopefully you've got time. Next live stream, I'll come up with a list. Yeah, every Monday, I'm looking to plan to stream every Monday from 4 to 5, 4 to 5 Pacific time, which is 7 to 8 or 7 to 8:30 or so on Eastern time. So hopefully I'll see you again. And yeah, just to leave you with what the question you asked was, math was my strongest section. That would make sense if you've done a lot of math, right? Because the math, as I said, is just, do you know this topic or not, right? Have you seen logarithms before? Have you seen matrices before? If you haven't, those questions are impossible. If you have, you get them right. With the reading, it's totally different. With the science and the English, totally different. So a good resource to go to for the English, just as a, hey, what do you do right now? A good resource for the English would be to go to the Purdue OWL, right? I'll just type that out. So you have the spelling. The Purdue OWL, you've probably used OWL before when you're looking at how to make a bibliography or something like that for an English project or an essay. But on that Purdue OWL website, they've got a bunch of stuff about grammar and mechanics and style and some really great practice problems to work on there. Everything you'd ever want to know about how to use a comma or a semicolon or what a conjunctive adverb is, all of that stuff is open source. It's available to you. So go and use that. Make sure you know the rules first. A lot of students will go into their exam and to practice, they'll just do a bunch of practice exams over and over and over again and expect that to help them improve their score. But if you don't know the rules, you're not going to get any better, right? If you don't know the fundamentals, you're not going to get any better. So for the English, make sure you go and learn the basics. It's not that hard. Again, there's lots of examples there on the Purdue OWL. For the reading, if you're doing SAT, read more. Yeah, come back later. If you're doing SAT, read more, obviously. They're a little bit more analytical on that exam. But again, with the ACT, it's just, do you know how to pick details out? For me, I read the questions ahead of time and circle what details I need and go and find them. It's more hide and seek than anything else. The same is true on the science portion. Okay. So back to that question. Get the sun out of here. So back to that question I was looking at earlier. The issue with that problem, the math problem here, is that you look at it and there's lots of things that may occur to you that you remember back from Algebra 1 or Algebra 2, and not all of them are helpful, right? Again, a steadfast strategy is to just plug in and see what you get. That doesn't help you here. If you happen to not know long division, if you happen to not know synthetic division, this becomes a decently difficult problem if you don't know how to factor polynomials very well, especially given one root. That should be pretty second nature to you. But given a root, if you don't know how to find the polynomial that remains, that might be an issue. You might end up just trying to plug and chug. I don't know that would be a really good strategy here. If you just try plugging in numbers, right, starting with 1 and 2 and 3 and hoping something works and seeing what the signs of those are, you could do that. But again, the best thing to do there would just be to plug it into your graphing calculator and see what the roots are, right? Go to the graph and find the roots. This is not a really big function, right? Around 0, it's not going to get too high, it's not going to get too low. If you were to see that this does not cross the x-axis more than once, then that means you've got a complex root, right? It means you've got 2 complex roots. So to think about that, if you find that there's only one root, hey, I've got some complex roots, I'm narrowing down to j and k. At that point, you have to know that if you've got one complex root and the coefficients in that polynomial are all real numbers, then you have to have the complex conjugate of that root as well, right? So for example, if I know, let's just say that 3 minus 2i were a root for this equation, then 3 plus 2i has to be a root as well, right? Those are complex conjugate pairs. They always come together. So if you got one complex root, you've got to have another, and so we'd have to look at choice K there. So again, just graph it and see what works. Bring your graphing calculator, right? A lot of students will always ask, hey, well, what graphing calculator should I use if I don't already have one? Get a TI-84 or a TI-83. You can get them for like $30 on eBay or a free and for sale page on Facebook. Don't spend $120 to get, the new fancy one with the color screens. That will never help you. There's nothing useful about that for you. So get yourself a TI-84 or a TI-83. The Nspire is really nice. I have that. I got it a long time ago. I regret spending money on it because I don't need multivariable graphing. I'm not working in engineering, so I don't need that. Get a TI-84 or 83. If you get a Casio, that's okay. It's just that most people are more familiar with the TI graphing calculators, and so more people are going to be able to help you. You're going to be able to find more resources that are specific to the TI calculators. Let me pull up an English question if we don't have any specific questions out there. Pull up an English question. Let me go back to A10 again and try and bring something in there. Okay. So go ahead and grab just a couple of these questions and I'll clear this over here. Okay. So these are some questions from the English portion of A10, and these are not ones, again, that I'm actually just kind of picking these randomly to go over a couple of English topics. But if you're following along, make sure that you understand why I'm giving each of these answers that I'm going to give. Right? It's one thing to just settle on, okay, I know a rule, I got it, it seems easy. It's a totally separate thing to be able to take your answer from one question and apply that to other situations that are similar, right? So let's see. Let me move this up just a little bit. And this first question here, we're actually going to run into an issue right off the bat. This first question here, it says, given that all the choices are true, which one provides the most effective introduction to the paragraph? Now, I've taken this from the middle of a passage. You can even see that this is from paragraph 5 of this passage. So a lot of times when people see an introduction problem, they think, okay, hey, my middle school teacher taught me introduction means introduce ideas. All right, so that's definitely part of it. You also want to link to previous ideas. So let me bring the paragraph before that into focus, just so we have an idea of where we were ending right before. Again, if you're ever doing an intro, you need to recognize that an intro is glue, right? And you glue two things together. You've got to go from somewhere to somewhere else. An intro tells you what's the relationship between what I just said and what I'm about to say. So let me actually bring in that previous paragraph there. And the previous paragraph, just to read it really quickly, I'll keep it off on the side. It says, okay, I'll just read the last couple of sentences. Despite enduring such harsh conditions, most turbine blades only need a thorough cleaning, such as a new coat of paint, other than basic stuff. Okay, sometimes the task can be more complicated, patching fiberglass damage from a lightning strike, for example. Okay, so that's where we end off in the previous paragraph, right? So we want to transition from that information, hey, sometimes there can be a little bit more damage, to the next information. The sentence after tells us technicians work in pairs, they don't climb in high winds. Okay, so this information about the wind turbine blades are over 270 feet long. There's two things we want to look at, and I'll be quick. Is it introducing the information to come, and does it relate to the information that came before? The information that came before was, hey, the repair can be more complicated. The information that comes after is the technicians work in pairs, right? Extreme temperatures, precipitation, right? They stay on the ground. Precautions such as these. I like that word because I see safety here, okay? So they're 270 feet long, totally irrelevant at this point, right? Totally irrelevant. They're not talking about the turbines anymore. They're talking about the task of repair. The number of jobs has doubled. They don't mention that, right? That, again, is in that category of we have to introduce the things to come. And a typical wind turbine has about 8,000 parts. That's pretty complicated, right? And it does say sometimes the task is more complicated, but of course this next paragraph goes on to talk about all of the precautions, right? The things that the actual workers have to worry about. And so I really like choice J, right? It introduces the idea of safety being the first priority, and we've got a really nice tie back to the previous paragraph, right? Whatever the job. Hey, sometimes it's really rough, sometimes it's really easy, right? It can be really complicated, but whatever the job, safety is the first priority. Again, glue between those two paragraphs. I like choice J on that question there. Okay, right into the next one. 39, it says technicians work in pairs while they don't climb in the high winds, extreme temperatures, or precipitation. Okay, a couple of things to look at here. I've got a semicolon, and a semicolon always separates two complete sentences. It's just like a period. And so the question I want to ask myself is, okay, well, do I have two complete sentences here? So technicians work in pairs, that's a complete sentence, right? Subject and verb is there. While they don't climb in high winds, extreme temperatures, or precipitation. I've got an issue here, and that's that while is a subordinating conjunction, right? That begins a dependent clause. And so when I see while, that's going to kill any verb that comes after, right? While they don't climb, this is an introductory statement, right? It needs to be linked on to another complete statement. It's a dependent clause. While is a dependent clause marker, kills all the verbs that come after it. And so I don't have two separate sentences here. So that's no good. Now, B is comma and, that's a fanboy, right? Linking two complete sentences with a coordinating conjunction, also not okay. And choice C says technicians work in pairs while they don't climb in high winds, extreme temperatures, or precipitations. So there's actually a really important difference between C and D, because while can have a couple of different roles depending on where it's used, and oftentimes depending on whether it comes after a comma. So while after a comma means contrast, right? While after a comma means contrast. My mom likes mac and cheese while my dad doesn't like it. Okay. While with no comma means we're talking about something that happened during another event, right? Somebody does this while they're doing this. All right. So the question here is there contrast, or is this a during type situation? If it's during, no comma. If it's contrast, a comma there. So they work in pairs while they don't climb in high winds, extreme temperatures, or precipitation. Are those two opposing ideas? They don't climb in high winds, they work in pairs. Let's look at the next sentence. Maybe it feels a little bit weird. So there's lightning within 30 miles, the technicians stay on the ground. Probably going to be unless there, I'm jumping the gun. Or if makes a little bit more sense, right? They're going to stay on the ground if there's lightning within 30 miles. They work in pairs, they don't climb in high winds. I actually happened upon a pretty decently tough question. That's good. Work in pairs while they don't climb in high winds, extreme temperatures. And go back to that first sentence. Whatever the job, safety is the first priority. Technicians work in pairs. Oh, I'm a dummy. I'm a dummy. You're probably commenting this right now. If I look at choice B, if I take away the while, the second part's not a subordinating conjunction, right? If I get rid of the while, this is now actually a complete sentence, complete with subject verb. If I get rid of that word, and this is why the confusion, that's why C and D didn't make any sense. If I get rid of that while, this is a complete sentence. They don't climb in high winds. So I was a little bit wrong with saying B goes away because yes, it's true, if I use comma and, I need to be linking to complete sentences, and when I get rid of that while, this second clause actually becomes an independent clause. It becomes a complete sentence. Okay, so a couple of important things to look at really quickly there. The distinction between while with a comma and while with no comma is still an important one, and that's something that you should be aware of. Also, if you ever find yourself in a situation where you go, this seems really complicated, right? This seems really complicated. Start looking around. See if there's something that you're not noticing. Reassess the question and really take stock of whether all of the assumptions you've made up to this point are correct. Okay, so when you do something wrong, learn from it, right? Don't just continue to move forward and make the same mistakes again. Okay. You asked me, could I do a matrix problem after the English stuff? Yeah, let me just clear this here and I'll look at matrices and go over just a couple of things you probably want to know about them. All of the matrix questions on ACT up to this point have been relatively easy. They're not doing any kind of complex linear algebra stuff. It's really just straightforward. Do you understand basics? Okay. The thing about a matrix is it's nothing, right? A matrix is nothing new to you. If I were to give you the equation, let's say 3x plus 5y equals 9. And then I gave you another equation that said, you know, x minus y equals 7. You'd be able to solve this, right? This is a really basic pre-algebra question, or maybe an algebra 1 question. I could use substitution, I could use elimination, I could graph, whatever. And now when I say, okay, well, hey, what's really important about this equation is just the numbers, right? The variables themselves don't matter. I could call x z, I could call y a, b, c, d, whatever variable I want, and it wouldn't make a difference, right? So those are totally arbitrary. It's the numbers, right? It's the actual coefficients on those values or on those variables that matters, okay? So what a matrix says is, okay, well, let's just assess the coefficients. Indeed, if I'm looking at a coefficient matrix, right, we literally just write down the coefficients. There was one question a few months ago on an ACT that just said, hey, what's the coefficient matrix here? Well, it's just that. The usefulness of breaking something down into a matrix is that then I don't have to worry about losing control of my variables, right? Oftentimes what happens when we're doing elimination or substitution, especially on maybe like 3 or 4 variable problems, is that I'll make some algebraic mistake where I subtract 5x, but I actually write, you know, plus 7x in my mind. So if I don't have the variables there, it gives me a little bit less freedom to make mistakes. Okay, there's some things I can do with the matrix that are helpful. You've seen the determinant before. In fact, if you go to the matrix section of your calculator, right, you go to the matrix menu and you go to math, you'll find determinant. The determinant of a matrix is just a value, right? It's just an integer or potentially a fraction. And all it tells you is whether that matrix has an inverse, okay? So just a couple of fun things to know about the determinant of a matrix. It tells you if it has an inverse, right? If it's equal to 0, there's no inverse. If it's equal to some value, right, not equal to 0, there's an inverse, all right? Usually on ACT, you'll see, you know, hey, maybe 7x 1 4, this is equal to 5, and these bars here mean determinant. With a 2 by 2 matrix like this, you know that, okay, well, I'm going to do 28, right? 7 times 4 minus x times 1 is equal to 5, and so I could solve something real basic like that. You asked where that section is on the calculator. Let me bring in give me 1 second. Let me bring in my graphing calculator here, the emulator, and I'll just show you. Okay. Let me bring back up the whiteboard. And then I'll try and bring in the graphing calculator there. Oh no, the whiteboard is very finicky. Classic Microsoft. Okay, I'll just re-stretch the window there and show you the whiteboard, and then I'll show you instead the TI-84. So really quickly here, we've got the TI-84, and again, just this is the emulator. Don't get the plus C, it's a waste. The matrix is right here. Hopefully you can see it. It's on the x to the minus 1. If I go to second and hit x to the minus 1, I get the matrix menu. Okay, and within that menu, you can create a matrix. Right? So if I go here, I hit 1, or I can just hit enter on 1, it'll show me what that matrix was, and right now it's empty, right? It's undefined. So we'll go back into that matrix menu, and to actually create a matrix, I go over to the edit menu, so I can edit what's stored in the calculator as A. Maybe I want to do, for example, a 2 by 2 matrix, and so I can go in item-wise and define any matrix that I want. What's important is that your calculator is only going to be able to deal with matrices that have values in them. Okay, so if you get a matrix problem that involves variables within the matrix, your calculator is not going to be able to do that. Maybe a TI Inspire or something with a computer algebra system might be able to handle that, but most calculators aren't going to be able to solve those for you. So once we're in the, let me make this a little bit bigger. You can't see very well at all. Make that a little bit bigger. Okay, so hopefully you can see that. Hopefully it'll extend on your screens. But again, just to show you where I got to that, I went to second x to the minus 1. That's your matrix menu. I went over to edit, and editing matrix A. I edited that there. Now I can go back to the matrix menu and I can go to math. There's a lot of different things that are here. DET is determinant, right? That's what I was talking about with the determinant. This T here will give you the transpose. There's a couple other things here that you probably won't use. I hit up and went to the bottom here. We've got ref and rref. Those are really useful, especially rref. That's going to allow me to use matrices to actually solve equations. But this is where the matrix menu is on your calculator. Okay. All right. So back to that question there. You said you have the Inspire CX. Oh, I don't know. As a matter of fact, I'll show you. My calculator is an old Inspire. but I actually took the TI Nspire keypad out so that I could get the 84 because the Nspire CX was really confusing to me. Honestly, I'm not sure where that is, which is why, again, as I said earlier, probably a good idea to invest in an 84 or an 83. I know the Nspire looks really pretty, and it's got all of the letters on it, which is nice, but it's really confusing. The TI-89 is also pretty confusing, I feel, to use. And again, a lot of teachers are not very familiar with the layout there. So a lot of guides online probably aren't going to be specific to the Nspire. So really would highly recommend getting an 84 or an 83 if you can. Again, you can get them for 20, 30 bucks on eBay or a free and for sale page around you. So sorry I couldn't show you that, but if you got the TI-84, that's where you find the matrices. And a couple of things there. Let's say I have this matrix and I want to actually do something with it, right? I want to actually use this to solve a problem. Then what I can do is, at least here, right, I took a determinant and that was nice, okay? What I could also do is create a matrix that we say is called the augmented matrix. It's the coefficient matrix, and then I also add on the answers, if you will. So I'm just going to take that original expression, 3, 1, 5, minus 1, 9, and 7. Some of you might be having flashbacks to Algebra 2 where you remember doing the Cramer's rule problems that are totally useless to you. So this is the augmented matrix, and all this is saying is, hey, I've got some numbers, let's do something with them. The great thing is I want to solve, in this original expression, I want to solve for x and y. Well, the calculator will do that for me. And so I'm going to take this matrix, and what I'll do is I'll put it in RREF form, right, reduced row echelon form. And what that's going to do is it's going to convert that, let me go ahead and move this up again, it's going to convert that matrix so that you only have 1, 1, 0, 0, and then you get your value for x and y on the right-hand side. So your calculator will actually solve these systems of equations for you if you give them in matrix form. It's not necessarily the easiest way to go about solving a system of equations. If you do have a TI Nspire with a computer algebra system, just plug in, right, 2x plus 3y plus 7z is equal to 9, right? Just plug them in and it'll solve it for you. But if you got the TI-84, one of the reasons that you use matrices is that you can solve algebra problems with them. So if I take this original matrix, and let me again show you how I would put that into the TI-84. So I'll go over to Edit, and I'm going to make here, and this is really important to know, the dimensions of a matrix are the number of rows by the number of columns. So if I look at the matrix that I had earlier, this was a 2 by 3 matrix, right? I've got 2 rows and then 3 columns. So I want to enter a 2 by 3 matrix into my calculator. So go ahead and enter in a 2 by 3. And I'll just enter those in line-wise really quickly. I've got 3, 5, 9, and when you're doing this on the calculator, this is really rapid. Okay, so I've entered that in. I'm going to go ahead and quit. I'm going to go back to that home screen, and I want to get me the matrix math menu again. I'm going to hit up because RREF is at the bottom. So I'll go to RREF, or I could actually hit apps here. That would go to the B button. But I'll go to RREF, and I want to do RREF on matrix A, or sorry, in this case I actually entered it in B. So I'll do RF on B, and that'll spit this out. So those are the x and y values that solve this equation, right? Very little work involved. It's just plugging it in and letting the calculator solve it for you. If you use matrices to solve systems of equations, you can actually just have kind of a dummy 2 by 3 matrix already pre-programmed into your calculator. Really easy, just go in, enter them, go to RREF, you've got your equation solved. Some people will run into issues when the equations don't give you nice solutions and all of the answers are in terms of fractions. So if you get a matrix answer like this, and let's say the answer for x is 3.17981, okay, something that's really unintelligible to you, then go ahead and go to math, and that very first option there is 2frac. right? So that'll convert your matrix into a matrix of fractions, and so you've got your values there in something that may be a little more intelligible, or more importantly, that may actually show up in the answer question or the answer choices. That's something that happens really often. A student will get, they'll simplify everything out. They'll get 2/7 as their answers say. So they do all the algebra, they get this answer, and then the answers on the exam are all in terms of fractions, and they go, oh no. And so they go, okay, well, let me try out the first one, let me try out the second one, see if any of those is equal to this. Even easier, just math frac, right? It's 2 button clicks to get to math frac, right? Math, enter, enter, 3 button clicks. And it'll tell you exactly what it is. The reverse is true too if you ever want to know a decimal, right? If you go into that math section, the 2 decimal will accomplish that for you as well. I know on the TI Inspire there's going to be something similar. Let me switch back. There's going to be something similar, so no problem. You said I'd graph both equations and then find the intersections. Of course that would work, right? Back in Algebra 1 and Algebra 2, you learned a number of different ways to solve these problems. If you look at this problem, right, the original problem that I had here, if your first instinct is to graph this, we probably want to change that first instinct, right? That is not the most ideal way of solving this problem, at least quickly. But it would work, of course, right? If you plugged those in, you said you would convert it into slope-intercept form, you would graph both of those, you'd find the intercept, that would get you the x and y solutions. Totally viable, but pretty time-consuming, and the other issue I have with that is that it's easy to convert incorrectly, right? It's really, really easy to make a small algebraic mistake. Like, for example, I've got 3x plus 5y equals 9, and I'm trying to get that into slope-intercept form, so I say, okay, 5y is equal to 3x plus 9, and then I graph this incorrectly, right? Whereas this should be a negative, I left it off. The niceness of the matrix solution is that I don't have to worry about moving anything around. I just literally plug in from the standard form exactly what's there. Now, that said, I also wouldn't use a matrix to solve this particular problem, right? I would just use substitution, right? I would just say, okay, I've got this expression here. Let me clear these out of the way. I've got this expression here, and I can find really simply that x is equal to y plus 7, right? I just move that y over, and then I can substitute that y plus 7 for x here. And then I'll get one equation, one unknown. That's a really simple pre-algebra problem at that point, and you've got it down. You also have learned, in addition to substitution, you've learned elimination, right? I very well could have, multiplied this second equation by 3 and then subtracted that from the first to cancel out the x's, and then I would leave y. That's an even quicker way of solving that problem. So there's lots of different ways, and I think one of the issues that students have is that they learn one way and then they stick to it and they go, that's where I'm comfortable, that feels like home to me. That's not what you want to do, especially in mathematics, when there are easier options available to you, right? So I have a lot of students who would get that problem. They say, okay, great, I have my calculator, I'll just plug them in and graph it. I think indeed on the TI-84 or the TI Inspire, you don't even have to change it to slope-intercept form. I think you can just write this out in standard form. But yeah, it would work. Have more strategies in your back pocket, right? That way, if you come across a question and you go, okay, I've got 10 seconds to solve this problem, you go, well, can I do this? No, that would take a little while. Maybe I could try this, maybe I could try this. And again, that's where it really, really makes a difference in going back and revisiting stuff maybe from Algebra 1 or even kind of the basics of geometry, where you've gotten so locked into your strategy that now there's no way you can get away from it. You're still young, right? You're high schoolers. You want to break those habits, right? You want to get away from just kind of steadfastly sticking to the same methodology for all of your problems. So I hope I answered your question there. Back to the idea of the matrix. Let's just clear this out of the way and look at a few other things regarding matrices. if I, for example, have, again, a 2 by 2, let's just say I have A, B, C, D. One of the first things that you need to know is that, again, this is a 2 by 2, right? There are 2 rows, there are 2 columns, so we have to know dimensions. You know dimensions, you're good. We also want to know how to just solve for the basic determinant of a 2 by 2, right? I told you that that's also, if I call this matrix A, for example, I put bars around A, and that means determinant of A. Okay? In this case, for a 2 by 2, it's the difference of the diagonals, right? AD minus BC. So that's real easy. Oftentimes, again, like I said earlier, they'll give you, hey, the determinant of x minus 7 to x is 5. Okay, solve for x. So you just multiply those out, you get a nice little quadratic, and you solve. Another thing you want to know is what's called scalar multiplication, right? So if I have 2 times matrix A on the outside, then I just multiply that 2 everywhere. So 2A, 2B, 2C, 2D, for example. Okay. Now, not always are we multiplying by a scalar, but sometimes we want to multiply 2 matrices together. And that's a little bit more involved of a process. So if I want to multiply 2 matrices together, then I have to check for something, and that's that the dimensions are going to allow me to multiply. So if I have matrix A and I want to multiply it by matrix B, matrix A is going to have dimensions, let's say, m by n. And if I can multiply A by B, then this dimension of B has to be n. And this could be anything. I'll call it Q. And that product C, again, those inner dimensions have to match, right? The number of rows in the second has to match the number of columns in the first. Then the resulting dimensions are the outer dimensions there. So I'm going to result in an m by q matrix. So if, for example, I've got, say, I'll just do a really, really easy one. Let's do 1, 2, 3, 4. This has 2 columns, right? This is a 2 by 2. So the number of rows in that second matrix has to be 2. And then I could have as many columns as I wanted. So I could do 1, 2, 3, 4, 5, 6. So I do a 2 by 2, and this is going to be, of course, a 2 by 3, like we saw earlier, and that will give me a 2 by 3, right? So it'll be 1, 2, 3, 1, 2, 3 values here. Okay, so oftentimes they won't actually make you do the multiplication. They'll just ask you, hey, can I multiply it, right? Under which conditions could I multiply these 2 matrices? Really quickly, just kind of what the algorithm is here for finding each of these values in the product, if you ever get asked that. And again, your calculator will do that, right? If I plug in matrix A times matrix B, it'll do that matrix multiplication. But if you've got variables involved, you have to solve it by hand. So I'm just going to look at this value here in this product matrix. That's in the first row, and it's in the second column. Right? It's in the first row and it's in the second column. So I'm going to take the first row of the first and the second column of the second, and I'm going to multiply the values within. Right? So I'm going to take the first one here, multiply it by that. I'm going to take the second one here and multiply it by that. Again, I'm first row, second column, because here I'm first row, second column. I'll multiply those out. I'm going to do 1 times 2 and then plus 2 times 5, right? So again, kind of like you're foiling almost, but only the outer terms, right? So I've got 2 plus 10 here. That gives me 12, and that means that this value in that product matrix is 12. And so I could do that for all 6, right? If I wanted to know this one, well, okay, that's in the second row and the third column. So I would go ahead and I'll do this one in blue. I would go ahead and take the second row here and the third column and multiply those together. That's going to be 9 plus 24. So this value here, 9 plus 24, always check your algebra. That's going to be 33. Okay, so that usually is all ACT will ask you to do with matrices. Again, remember that definition, right? The coefficient matrix. Just take the values in the original expression, put brackets around it, right? That's all that means. You said, I completely forgot geometry. Could you go over all the basics I would need? Well, There is a lot. So you say your strong suit is definitely trig and algebra. So if you feel really confident in trig, most of the geometry questions that you'll see are probably not going to be very difficult for you. Even circle questions usually will boil down to some sort of triangle, right? Which is why we learn trigonometry so much, right? That's why we spend so much time on it. But let me look at, for example, this is a really common type of question that comes up all the time. Let's say, for example, I've got a circle and I tell you, okay, I've got an angle here of, let's say 70 degrees. And I tell you, okay, the area of this circle is, let's make it something easy. Let's call it 9 pi. And then I give you this arc here, right? This arc. So that's just this piece from here to here, and I'll draw it in blue just to be a little bit clearer. So I want to know the length of this piece. Well, I could just try and estimate it. That's probably not a very good idea, because if I say, okay, the whole thing around is 9 pi, that's not very helpful for me. This ends up being, for example, a really simple proportions question, right? Where I can say, okay, well, this is 70 out of 3/60ths the way out, right? 70 out of 3/60ths the way around, and that's going to equal x over their circumference, for example. I'm assuming that's pretty straightforward to you. So the thing about geometry questions is they're usually not geometry questions so much as just kind of, can you take a shape and then translate that to an algebra question, right? That's really all geometry is. It's just algebra, but based on a shape. A couple of things there, just about geometry, kind of, real basic in geometry. Move up. Oh, it won't move up. Okay, I'll just clear it. Real basics in geometry. If I've got something, let's just think of circles, because I brought that up. The only things you need to know about circles are, hey, area is equal to pi r squared, right? You know that the circumference is equal to 2 pi r, and this, if I'm graphing it, is x minus h squared plus y minus k squared equals r squared. People usually forget the squared there. Make sure you don't forget that. Easy, right? Straightforward, basic. When you're dealing with triangles, area is 1/2 base times height. I almost don't even want to write these down. But I will anyways. If I'm dealing with triangles, I know, hey, area is equal to 1/2 base times height. Okay. Somebody will go, okay, well, oh, I remember there was a formula for equilateral triangles and the area. And so let's say I get a question like this on the ACT. I've got a triangle. I tell you it's equilateral, or maybe I tell you this is 60 and this is 60 and this is 7. And I ask you, okay, well, what's the area of this triangle equal to? Now, if you remember one of your rules back from geometry, you say, okay, hey, great. I know that for an equilateral triangle, the area happens to be √3/4s squared, okay, or b squared, whatever you call that. That's really great if you remember that, and that's probably an answer choice anyways, right? Like 49/4√3. But if you don't remember that, what's really important on the exam, and this is going to apply to most of the geometry stuff, what's really important is if you don't remember that, you don't kind of start getting anxious and say, okay, well, I have to remember that in order to figure out this problem. Break it down into something that you're really familiar with. That's kind of what the math ends up being. Break seemingly complicated problems down into things that you know and are really familiar with. So, for example, I could break up this equilateral triangle into a 30, 60, 90 triangle, right? I can use Pythagorean theorem on this. I know ratios with sine, cosine, and tangent. So if your trig is strong, I can take an equilateral triangle and break that into something that I'm really familiar with, okay? Now, of course, I know the area is 1/2 base times height. I could turn this sideways, right? The base is 7, so this base is also 7. And if I cut it down in half, just this little piece here is 3.5. Again, at this point, right triangle, even if you don't remember your 30, 60, 90 rules, no problem. Pythagorean theorem, right? Your calculator will figure out what 7 squared minus 3.5 squared is, so you can get that last side, and then you've got 1/2 base times height, right? So what I would say is if you confidently feel that your strong suit is trig, or rather your strong suits are trig and algebra, then try your best to turn geometry problems into trig and algebra problems. you said, for example, here, I would use sine for that. That's perfect, right? If I wanted to find x, you totally could use sine there. You'd say, okay, well, hey, I know sine of 60 is equal to, okay, so good, so opposite over hypotenuse. Okay, that's equal to x over 7. You can solve for x there. Make sure, of course, when you plug back in, you remember the 1/2 and the whole base is 7 times that height x. Also, if you happen to not know sine of 60 off the top of your head, which I would hope you do, it's going to be root 3 over 2, which is why when I multiply it by 1/2, I get that root 3 over 4. Make sure if you put this into your calculator, you're in degree mode, right? Make sure you're in degree mode. For those of you with the TI-84, the way to figure out whether you're in degree mode, depending on your operating system, but it'll tell you up at the top right here, degree or radian. And if you're not in that mode, right now I am in degree, but if I were in radians, it would tell me here in the mode menu. Again, go back to the beginning, I hit that mode button, and I can switch there between radians and degrees. On the older operating systems, it doesn't display what mode you're in at the top, so just always be sure, right? Because if I'm in radians mode, let me just switch over to radians really quickly. If I'm in radians mode, this is a disaster, right? If I try and solve this with sine. If I go ahead and do sine of 60, that is not root 3 over 2. In fact, it's actually a negative value. If I were to do root 3 over 2, I get a totally different value. Not even, whoops, I want root 3 over 2, so divide that by 4. So that's root 3 over 2, not even close, right? So again, I think this is a good example. Let me bring back the original screen there. I think this is a good example of a type of instance or a situation wherein you can solve the problem, but you're making it a little bit more complicated on yourself, right? If I look at this situation and I say, oh, okay, I'll just use sine, well, I say, well, that could go wrong, right? I know there's the degree radian issue. This is something more basic, right? This just, again, ends up being a Pythagorean theorem question. And notice, you could turn this into a parallelogram and think of it that way, and that's a bad idea. Don't do that. This is just a Pythagorean theorem question at this point, right? If I just gave you this and said this is 3.5, and you're not going to be able to see this, let me move it over. If I just gave you this and said, okay, well that's 3.5 and 7, what's x? And of course I would tell you, hey, that's a right triangle. If you don't know these angles, you can't use sine, right? You can't always default for that. So that would work, right? Sine would totally work, but again, just make sure you have other options in your back pocket, okay? Let me get rid of this here. Just because you asked, let me see if I can find a geometry question on a more recent exam that isn't directly to do with trig. Looking at A10 here. Number 49 on A10 I've seen done a lot. In fact, I made a video last night to solve that. I'm looking through and here's I guess this is a geometry question. So I've got this here. So it says, I've got this situation. I want to know what's the distance between these two radar stations, for example. This is, again, the geometry questions that I was able to find on A10 all just boil down to trig problems, right? If I see this question, again, this is 32 on A10. It's just a trig problem, right? It's just breaking things down. If I want to find, for example, this little piece here. Now, they told me that I've got two stations, A and B. So I want to find this distance here. Okay. There's a couple of ways that I could look at this. And for the smart test takers out there, you would just look at this and say, okay, based on the answers, it's 14,000, and then move on, right? And the reason for that is that you anticipate the mistake that ACT thinks you'll make, which is that you'll solve for x and then you won't actually go back and do the problem. You'll just write down what x was. So we're going to end up finding that x is equal to 5,000. Notice then if you forget to add that back, you'd get the wrong answer. The right answer is going to be 14,000, right? So without even looking at the problem and doing the math, we could figure that out. But that said, here's just a very simple Pythagorean theorem question, right? I just, again, looking at A10, pulled a geometry question that wasn't number 49, and it's all trig, right? Everything's going to get broken down into trig. So again, if that's your strong place, if you're comfortable there, take circles and squares and parallelograms and diamonds, rhombuses, whatever, trapezoids, and then break them down into trig problems, right? Break them down into things that you're more familiar with. You can always draw triangles, and usually the problems then become pretty easy. Your question is, will trig identities be tested on the ACT? Yes. I've seen them tested in some interesting ways. So, you know, if you had a pretty good pre-calculus teacher, he or she probably had you do some pretty difficult questions with trig identities where you would do, you know, hey, what's, like, for example, sine of alpha plus beta? And maybe a lot of you have forgotten what sine of alpha plus beta is. And that's probably not going to come up on the exam. Just to jog your memory, what I'm talking about, this, for example, is sine alpha cosine beta plus cosine alpha sine beta. And you can use that to your advantage in some situations. You're probably not going to see that. Here's what you definitely need to know on the ACT. Okay, so you're probably not going to be dealing with stuff like this. You're going to be dealing with the Pythagorean identity, which is that sine squared plus cosine squared is equal to 1. You have to know that. That comes up in lots of different applications. You have to know that, right? So sine squared of any angle plus cosine squared of that same angle is always 1. If I take that expression and I divide by sine squared, then I get another expression. This becomes 1 plus cotangent squared is equal to cosecant squared. And if I take that first expression and I divide by cosine squared, then I get tangent squared, right? That's going to be sine squared over cosine squared plus 1 is equal to secant squared. So these you really have to know, and those will come up in some different contexts. I even saw, for example, there was one that asked you, you know, what is the graph of y equals sine squared x plus cosine squared x? What does that look like? Well, hey, that's just a horizontal line, right? Because it's just y equals 1. So I've seen that come up. Other stuff for trig identities, again, with kind of like the plus and minuses. This first expression that I gave you, if they ever wanted you to use that, they would give that formula to you. Okay, they would absolutely give that formula to you. You should be familiar with law of cosines and law of sines problems. Those are very predictably easy. The patterns that come up on those are very similar. You can take a look at the video I have for A10 number 49. That's also a law of cosines question. So the thing about that is they'll give you law of cosines, they'll give you law of sines, and then you just have to plug in. So that's not particularly complicated. Notice that if I am looking at this expression here, I can use that to substitute, right? So for example, if I'm thinking about a trig identity problem, I could say, okay, hey, which of the following is equal to, you know, sine squared x minus cosine squared x, right? Which of the following is equal to sine squared minus cosine squared? What is that equal to? Okay, I'm just going to substitute, right? I know that 1 is equal to sine squared plus cosine squared, and so sine squared, for example, is 1 minus cosine squared. So I could plug, 1 minus cosine squared in here, and this equation becomes 1 minus 2 cosine squared x, right? And that may be an answer choice. So you might see that, right, where you have to kind of rearrange based on your Pythagorean identities. Another thing you could see come up, I have seen this, and it's helpful to know. You do probably want to know that sine of 2x is 2 sine x cosine x. That you probably want to know. That comes up pretty frequently in a lot of different contexts. Again, just have that in your back pocket. Kind of if you're throwing strategies at a question, see if that works or if that simplifies something. Especially if you see an answer choice that has this within it, and the question gave you sines and cosines together and you want to simplify that, this is pretty helpful. You know, cosine of 2x, I don't see that one come up as often. That's equal to cosine squared x minus sine squared x. You could actually get that from the first one. And again, with some substitution, you'll find that this is 2 cosine squared x minus 1, or 1 minus 2 sine squared x. Okay, so those are helpful. I don't see them as often, and again, they'll probably give them to you if you ever needed them to solve a problem. They're only helpful insofar as if you recognize that pattern, it may allow you to do your work a little bit more quickly, but I would probably say they're not going to ever ask you to just come up with those identities, right? The exam is not, do you remember your trig identities? It's, can you take what you know and solve some problems? So those are really helpful to know. I will say, though, that if you encounter in calculus trig problems, these identities are super, super helpful. So that's jumping the gun a little, but in Calc AB and Calc BC, these identities come up all over the place, and sometimes problems are impossible to solve without knowing your identities. Where would they be located on the test? It depends on the context, right? So you can't just assume, okay, I see a trig identity, so it's got to be tough, right? Oftentimes, again, within the problem, they're asking you something a little bit simpler, right? Just can you rearrange things and not get caught up with the difficulty? It depends on what the problem is. Because again, with trig identities, you could have a really tough trig identity problem, and you could have a really easy trig identity problem. For example, again, I told you they asked in one exam, just graph this, and I think that was on the later part of the exam. I think that was around number 50, and yet it's really easy, right? If you know your trig identity, you just plug in 1. I would say definitely probably within the last 15 or 20. That's not to say, though, that if you're on question number 30, you should tell yourself, oh, I couldn't possibly use a trig identity here because it's so early in the exam, right? So you know, it just depends on the exam. The thing about ACT is they're always experimenting, and they're always using you for data, right? They're trying to figure out what you do and don't know, and by you I mean high schoolers with across the country. So sometimes they may assume that something that is pretty easy and taught widely in schools, they may assume that, but then most students don't know it. So don't make those kinds of assumptions. Solve problems with ways that you know how to solve them, right? And if it's at the end of the exam, to answer your question in a slightly different way, a lot of students, when they get to the end of the exam, assume that questions have to be really difficult. That's not the case, right? If it's at the end of the exam, maybe it is just as simple as, okay, hey, I'm just gonna, all I need is to make this substitution, and then I've got my answer. So you know, again, it depends on the exam. I'd say last 10 or 15 is probably not a bad assumption, but you can never be sure. Let me go to 70C. I have that open. See if I can find a problem for you that actually uses anything relating to trig. I will say that on the older exams, you're not going to find those as often because they only more recently started testing knowledge of the trig identities. So if you're going back before maybe the kind of 74 or 73 series, you're probably not very likely to see them. Most of the questions are just SOHCAHTOA. Let me see if I can find something on the newest one, which was B5. And I'm pretty sure I remember seeing some trig stuff there with the identities. See if there's anything that would throw us for a loop. Okay, so yeah, here's actually a really, really good problem to think about this. So it looks as though it's a trig identity problem. I think it's kind of a trig identity problem in disguise. So it's asking, hey, what is 2 pi plus theta equal to for any given theta? So you could, on this question, you could use a trig identity, right? You could say, okay, well, I know sine of alpha plus beta, right? I gave that to you earlier. So, okay, hey, that's sine 2 pi times cosine theta plus cosine 2 pi times sine of theta, and hopefully you have your unit circle memorized. You know sine of 2 pi is 0, and you know cosine of 2 pi is just 1, right? That's cosine of 0, and so this just equates to sine theta. So there, knowing your trig identity, if you know it well and you're confident and just can plug in really quickly and know your unit circle, that becomes a 5-second question. What you said is I would just draw a unit circle and realize the answer is G, and absolutely, that's what I would do mentally, right? I would not write this out using my trig identities. I would say, hey, well, I know sine, right? The sine function is periodic for 2 pi, right? If I go around a circle 2 pi, it's just theta. If I take 0 and add 2 pi, it's really just 0, right? If I take theta, add 2 pi, it's coterminal. The sine value is the same. And so you just go straight to G. And so what I'm saying there is this is question 48. So I wouldn't want you to go, oh, it's later, so I have to use a trig identity, right? What you said is exactly right? Go to something that's familiar. Don't take a problem and make it more complicated because of its position in the exam, because you go, okay, well, I could use trig identities or something like that. You said, whenever I got 5 minutes left, I had 10 or more questions remaining. Any tips to go quicker after you find that trick question? Yeah. Well, the converse of what I've said is that usually the last 10 questions are a little bit more involved and do require you to have some knowledge of things that students are generally a little bit less familiar with, or things that are kind of really digging back into your Algebra 2 or geometry knowledge. So to go more quickly, if you've got 5 minutes left and 10 questions, your goal is, your goal in terms of preparation for the exam is not to go quickly in the last 10. Your goal is to go quickly for the whole exam. And part of that is what I said earlier when you asked, for example, about, solving a system of equations by graphing. That could take you 25, 30 seconds that you wouldn't need to spend, that would be far more useful at the end of the exam. So the thing about prepping for the math is that just because you know how to solve a problem doesn't mean you should stop there, right? Constantly ask yourself again, is there any way I could more quickly solve this problem? To answer your question directly, I'm at the end of the exam, what can I do? If you got 5 minutes, that's probably time at that rate to answer just a couple of questions. So what I would do is I would just skim over the last 10 if you're in that position and see if any of them looks easy to you, right? See if any of them looks really simple and go for those, right? The point of the exam is to get as many questions correct as you possibly can. So speeding up in the last 5 minutes is not going to help you. You should have been speeding up much before that. And if you feel really comfortable with these topics but still find that you're going slowly, go back again and reevaluate whether the strategies that you're using are proper and are consuming a lot of time, or whether they're really quick and kind of going for the easy thing. At the end of the day, if time is about to be called and you've still got 10 blanks at the end of the exam, bubble K or E for those last 10. For whatever reason, statistically, they're more likely to be E and K at the end. So that'll up your odds. But again, it's just a total crapshoot, right? If you've got 5 minutes left and 10 questions, you gotta make do, right? You gotta deal with problems elsewhere. Somebody asked a while ago, and I didn't see, could you go over the most important things to know for the science section? Yeah. The important thing about the science section is that it's not a science exam, right? It's really just kind of reading 2.0. I got just a couple of minutes here before I have to head away. So let me just look at what tends to be the really, really tough passages for people. Those are the opposing viewpoints, or kind of passage 1, passage 2, scientist 1, scientist 2, or student 1, student 2, whatever the situation. So let me take a look at one of those types of questions, one of those one of those passages here. We look at B5, and I'm looking at passage 5 from the science there. Make this a little bit bigger. And okay, so just want to tackle this really quickly, because this is a question that comes up really often for students. Is when I see lots of words, I go, oh my gosh, I'm done, right? I'm used to chemistry problems being 10 seconds long. I'm just used to doing basic stoichiometry, or hey, mitochondria is the powerhouse of the cell. I'm not used to seeing a lot of words when I'm thinking about science. So this type of passage usually poses some issues. The first thing that you want to do when you see a passage like this is read the background. Okay, for every other passage, I don't think it's very useful to read through everything. Okay, especially when they're just asking you, hey, in figure 1, right? What if I had done the experiment for 25 minutes, right? What would the concentration of this substance have been if I extrapolate? But when you see these types of passages, you want to read everything, at least so far as the background is concerned. Okay, so I know it's a little bit cut off there, but just looking at the beginning, I want to read this background. And whenever you see any italicized words, know them, right? Learn them. Take a quick second and internalize what those definitions are, so that when you see those terms in the passage, you don't go, oh, what the heck does poikilotherm mean? You know exactly what it means. It tells you in the passage what a poikilotherm is. Okay. So go ahead and read that background first. Then, based on that last sentence, right, they'll usually tell you, hey, the scientists did this, right? What do they do? Oh, here, they discussed the evolution of 3 animal groups. Okay, so they're going to have some kind of opposing viewpoints. Usually the setup is that the first paragraph tells you, here's why I think what I think. And the second one will tell you, here's why I disagree with scientist 2. And the same thing would be true for scientist 2, which is a little bit lower, right? In that second paragraph, here's why I disagree with scientist 1. Here's why I'm correct, right? Okay, so you read the background, and if I go into that first question, right, it says, hey, both scientists would likely agree that modern birds do what? A couple of things there. Modern birds, right? Modern birds. Where do I see that? Well, it told you here, right? I see modern birds is one of the things that they're talking about. Modern birds are just not crocodiles and not non-avian dinosaurs. Okay. So it tells me here something about, traits have been evolved for all modern birds, only became homeothermic after non-avian dinosaurs went extinct. They both agree to something. That's probably going to come from the first paragraph from each of these. Okay, I'll move that up just a bit. Probably going to come from the first paragraph of each of those 2 scientists. Yeah, that's what they think. So that's what's going to come there. As another keyword, by the way, if you say they both agree on something, sometimes that comes from the intro. Okay, so always read that background. If you see both scientists agree, probably is going to come from either the background or, again, just a consistency between the first paragraphs of each of those scientists' statements. Okay, don't go play hide and seek with no indication of what it is you're looking for. Okay, I want to know either what they evolved from, right? Where do they come from? Or have they always had a low RMR? Whatever the heck that means, doesn't matter. Have they always had bones with growth rings? Okay, and look at what it says. It says modern birds in the first scientist inherited these traits when they evolved from non-avian dinosaurs. And the second, modern birds ever since they evolved from non-avian dinosaurs. Good, found it, right? They evolved from non-avian dinosaurs, and I move on. Yeah. The issue with these types of passages, and I'll look at those other questions maybe in the future, but the issue that people have with these passages, they see a lot of words, they go, oh my God, I don't know what to do with this. Break it down into really small pieces. That's the name of the game for everything, right? Break the math problems especially down into smaller pieces. Break them into things that you're familiar with. Like I said, when I'm looking at the answer choices on 27 here, had a low RMR. It doesn't matter what that means. I don't have to understand the passage. I just have to know what it says, right? Okay, crocodiles had a low RMR, high RMR, right, et cetera, et cetera, et cetera. Modern birds inherited these traits, a high RMR. Okay, well, it's not that. You get the point. So keep it easy. Go easy on yourself. Don't look at hard questions and go, these are hard. Look at the questions on the ACT and say, if this feels hard to me, I'm probably making it way more complicated than it really is, right? Break it down into something that you're familiar with, and especially on these, really, they're reading passages on the science. Go piece by piece, right? I'll just look at question 28 really quickly, and then I'll head out of here. It says, scientist 2, would scientist 2 more likely expect to find bones that have growth rings in a crocodile or a modern bird? Okay. Now, again, what does scientist 2 say about growth rings? That's what I'm looking for, right? I'm looking for growth rings in scientist 2. So let's see if I find that anywhere. I'm skimming that first paragraph, and growth rings, I don't think I see growth rings anywhere. Okay, let's look at that second paragraph. Growth rings. Well, hey, the very first sentence, right? The bones of non-avian dinosaurs were dense and had growth rings. Okay, each of these indicates a low RMR. Okay, something, something, something. Okay, well, hey, each of these features, each means the stuff in the previous sentence, right? So dense growth rings, all right, so they had low RMR. Growth rings indicates low RMR. The reason that I'm writing that down is that I saw that in the explanation to the answers on 28, right? I know I'm looking for a connection between growth rings and RMR. Great. Scientist 2, I'm looking at the explanation for F. Oftentimes looking at the explanation helps you more than anything else. Growth rings indicate high RMR. No, we just found the exact opposite of that. So F is going to be wrong, and of course H is going to be wrong. All right, now would I find bones that have growth rings in a crocodile or in a modern bird? Well, I want to know then, if growth rings mean a low RMR, which of those two, right, the modern bird or the crocodile has a low RMR? And if I look at that first paragraph, I see that statement, right? Crocodiles evolved from a common ancestor that had low RMRs. Crocodiles retained these traits. These are low RMR, but modern birds have a high RMR. So that's going to be a crocodile, right? That's my low RMR, and I move on. Okay, so again, break things down into simple. Look for what you're skimming for, right? It's really just a skimming test. It's a game of hide and seek, but you have to know what it is you're looking for. If I just go in and say, okay, I'm going to read all these words and try to remember everything and try to leave the exam like I could give a lecture on poikilotherms versus homeotherms, that's a terrible idea. Just look for what you need. Answer your last question there. You said, what college did you go to? I went to UCLA. I majored in biochemistry. You're so helpful. Thank you. Thank you for being participating here. I got a 24 with minimal studying. I study 2 hours a week until June. What do you think my peak could be? Well, what's really important is that you really take stock of what that 24 means to you. Because when people are first starting to take the ACT, part of their difficulty is just a lack of familiarity with the exam. Like I mentioned earlier, when you're looking at the reading portion, you go, wait, they just want to know some tiny little detail in the first paragraph. They're not going to ask me to do analysis, right? They're not going to look for the deeper meaning. No, right? That's new to you. With math, you're used to doing things section by section, right? Okay, hey, this week we're going to cover matrices. Next week we're going to cover exponents. Next week we're going to cover logs. The ACT throws everything at you, right? So it's new, it's different, especially the science, right? It's a lack of familiarity at first. So assess whether that 24 means that that's kind of where you're starting, or whether that's your getting going score. Right? Once you become familiar with the exam and you start to see patterns and similarities between questions, then that really gives you a better idea of kind of what your starting score is. And the second part of your question is, I'm going to study two hours a week until June. 2 hours a week is not necessarily 2 hours a week. And what I mean by that is that if you spend that time going through exams and going, okay, well, can I get this right? Can I get this right? Can I get this right? That may be a pretty bad use of your time. Namely, if you're going through, for example, you're going through the English passages, right? And you just keep doing practice test after practice test after practice test, that doesn't reinforce any skills. right? All that does is, again, get you more familiar with the exam, but up to a point, right? And then after that, you're not going to make any improvement. You're going to stagnate. And the reason is that you're not building any skills, right? You're not actually learning the material that's on the exam. So if you find yourself getting to that point, again, go back for the English, go back to the Purdue OWL, right? Really strengthen those fundamentals. If you find yourself on the math section being really slow, part of that could be that you're trying really difficult methods to solve some of these problems. You said, for example, I'm gonna solve the Pythagorean theorem question by using sine and cosine. You could do that, right? You could graph a system of equations, but there are easier ways that are less time consuming. And even if it's that, just 10 or 15 seconds per question, by the time you get to question 50, that's an eternity. Right? That gives you basically a whole new testing period to try and attack those tough questions at the end. With the reading, it's probably speed, right? So the first thing you want to do is just try to get a little more reading into your life as best you can. For the science, it's a matter again of recognizing that it's not really a science test. It's just one game, just like the reading, of hide and seek. But you've got to know what it is you're looking for, right? If I come back here on number 27 and I just go, okay, well, let me read both passages again and see if the question jumps out to me. Well, no, right? There's no strategy in there, and you're going to spend a ton of time reading and just negatively reinforcing that kind of anxiety with all of these words. So to answer your question again, 2 hours a week, it depends on what you're doing. Right? It totally depends on what you're doing. If you're just looking at the exam and you go, okay, well, I guess I'm going to take 4 English tests today, that'll be my 2 hours, and hope that I get something out of it, you might get nothing out of it, right? That might be a total dead weight loss to you if you're not, again, building new skills. So that's the thing you have to look out for, right? Working more time doesn't necessarily convert to a higher score or any increased performance. You could ask athletes and they would tell you exactly that, right? You could walk on a treadmill for 5 hours and get nothing, or you go swimming for 5 minutes and get way more out of it. So keep that in mind. And what is your peak? 36? Your peak score is 36, right? I'll leave on that note. I think every student has the ability to get a 36. The types of questions, the topics and analysis that they want you to do and understand on this exam are really pretty fundamental. And that's why you get a lot of students on Reddit or on other places online, for example, saying, I didn't really study much and I got a 36. That's just because they recognize this is an easy exam. They're not asking that much of me. If I know my fundamentals and if I can read a passage in a couple of minutes and know what details I'm looking for and have kind of trained my memory to stay focused on a reading passage for a little while, then they're really not asking much. Right? Again, go to that Purdue OWL website, make sure you get your fundamentals down, crack open an Algebra 1 text, and yeah, hopefully I'll see you next week on Monday, same time, and yeah, continue your studying and come with questions, right? If you've got questions prepared, and now I've got the audio sorted out, so we won't have that issue next time. Come with questions and we can look at those a little bit more specifically. So thanks for tuning in. And I'll see you next week. Take care.